talk a little bit about advances in consumer neurotechnology. And this is not intended to be sort of a comprehensive overview of the space, but gives a little bit of a sense of where the technology in the consumer space currently is at, and some of the players in that space, and opportunities, as well as an announcement of a special issue that will be forthcoming soon on this topic in Frontiers. So I wanted to start by introducing again the definition of a brain-computer interface and its evolving definition. So the common definition of a BCI, or a brain-computer interface, is basically any system that measures central nervous system activity and can convert it into an artificial output that either replaces or restores or enhances, supplements, or improves natural CNS output, and in that manner changes interactions between the CNS and an external or internal environment. But that definition's been extended relatively recently to include other non-brain neural inputs, for instance, or outputs really, such as say eye tracking or the peripheral nervous system that might include like muscles, for instance. And there's some related terms like brain-machine interface, neuroprosthetic, and direct neural interface that collectively refer to the same thing with various shades of meaning. Neurotechnology is a broader definition of any technology that essentially has the capacity to measure and analyze chemical and electrical signals in the nervous system, and then to interact with the nervous system and change its activity. And so consumer neurotechnology is essentially the subset of neurotech applications that can be purchased directly by a consumer without the involvement of a researcher or a treating clinician. And there's another understanding of consumer neurotech that understands it as tech that enables the study of consumer behavior. So for instance, neuromarketing, but we're not going to consider that definition in this talk. So we're talking specifically about the direct-to-consumer applications, or DTC. Consumer neurotech tends to be personal, digital, and mobile. And here we're restricting our definition of consumer neurotech to technologies that can directly record or modulate neural activity, but potentially also in combination with other modalities. So in general, this includes brain neural computer interfaces mentioned earlier, as well as then personal neuromodulation devices that can change the brain state and are not traditionally considered brain-computer interfaces, although again, that general definition of neurotechnology encompasses the neuromodulation devices, which we do consider to be consumer neurotech. So what is consumer neurotech for? There's a lot of different variations on this theme, but one thought process when you say, well, if you think about the use of a product and you eliminate all the uses of a product that are medical, clinical, restorative, or repair oriented, then you can think that the ultimate purpose of consumer technology is essentially to contribute to, quote unquote, the good life of a user. And, and ideally in this sort of Aristotelian sense, these technologies contribute to a life of human flourishing. It's arguable whether or not consumer technology achieves that goal, but in some philosophical sense, that is the ultimate purpose of consumer technology as differentiated from clinical and medical technology that, again, is, while it does increase human flourishing by restoring capability, has other additional considerations to society and to the human using the technology. This is a slide adapted from Nicole Bradford, who leads the the Transformative Technology Academy and the Transformative Technology Conference. And she's identified 12 major areas of what she calls transformative technology, which is really technology intended to improve human flourishing, abundance, well-being, sort of satisfying core aspects of Maslow's hierarchy of needs. And in this, you can see things like sensor tech, data tech, neurotech, neurostim tech, biofeedback tech, biostim tech, perception tech, sleep tech, and app tech. Consumer neurotech encompasses some or all aspects of these. So it's very closely related as a major driver of emerging transformative technologies that are, again, really focused on human flourishing and human possibility, human potential. Here are some of the representative current and emerging applications of consumer neurotech. This is not exhaustive, this is a subset. Assistive BCIs basically, while they can be thought of as clinical or medical in nature, there's also consumer applications of this. These basically allow individuals to regain some function that might be lost due to damage to the central nervous system. Examples of that include communication devices that can also be extended to non-clinical applications for basically human-machine interaction. So the ability, for instance, to like control your environment using your brain or your thoughts in some way, perhaps to enhance or augment a interaction with a computer. This is an example of the Cognition 1 device that was recently announced by Cognition, a San Diego neurotech, or sorry, a Santa Barbara neurotech company. And this technology allows the user to spell out words using an augmented reality interface that can actually display those words. This is using neural responses and other metrics to a user. And this can be used by people who are not able to communicate, maybe cerebral palsy or ALS. Also could be thought of as ways of helping other people to communicate. NextMind is a French company that's developing technology that uses SSVPs to be able to interface and control environments, including virtual environments. So here the person's playing a game using their brain to essentially interact with the environment around them. This ability to use neurotech to interact with environments around you has a big potential application in AR or VR applications. This is an example of the Microsoft HoloLens. You can imagine the future of design, of computer interaction will be primarily driven through augmented reality interfaces. So you can think about these control interfaces as being a major component of that. This is Control Lab's interface, which basically tracks motor neuron activity through EMG, but it's actually tracking motor neuron activity and is 8 single units, I believe, through again, the muscle analog. And this allows for very precise mimicry of a person's overt motor actions, which could be used again to control a virtual device, a virtual interface, augmented reality interface. Control Labs was acquired by Facebook recently for a substantial sum, more than half $500 million. More than $500 million, $500 million, and with equity close to potentially $1 billion. The individuals here are able to interact with each other. Actually, the system is able to track the movement of a person's hand without them actually needing to flex their fingers or muscles, which is quite impressive. This again could enable new kinds of interfaces. Here's a person interacting in some kind of a virtual world, which in the future could be performed using these kinds of technologies. Another key application is augmented cognition and accelerated learning. This includes the ability to measure a person's neural state. For instance, in this case, measuring whether a person is making a mistake, detecting their event-related potentials that are associated with user errors. That can then be fed to a machine or a computer that is able to use that in cooperation with the person to augment or improve their cognition, also potentially to accelerate their learning. DARPA coined these systems Centaur systems, basically human AI hybrid systems that enhance the capabilities of a human by combining their neural activity and some kind of augmentative AI system. Another possibility in present and future consumer neurotech is quantified self, health, and wellness applications. So this includes a broad array of products for tracking, say, emotional function, brain function, sleep function. There's a number of products already on the market that seek to achieve this goal. Neuromodulation and brain-body optimization is another key sector. This includes things like targeted neurofeedback, This is a demonstration of an individual doing an augmented reality neurofeedback game that tracks brain activity in different brain regions and uses that to make these orbs levitate as you change the balance of activity in different localized brain regions and networks. This could be used through neuroplasticity to ultimately change neural function over repeated use. This is a more potent example of neuromodulation that is stimulating the brain or inhibiting brain circuits, in this case using transcranial focused ultrasound. And every time a pulse of ultrasound here is delivered, you can see the burst of activity in real time being imaged. This is using some of Inthion's technology and some of Jay Sanguinetti's research. And this has the potential, again, to change and modify neural circuits. And then entertainment experiences and art. This is an expanding area where the goal really is experiential, to enhance the ability of a human to tap into new areas of experience, creativity, consciousness. This actually was one of the earliest uses of neurotechnology, was in the experiential and artistic domains, and then expanded into entertainment. This is an example of something built by Intheon called the Avatar Experience. It's a unity fly-through of your own brain and body that includes multimodal tracking of brain activity and body activity and feedback. So you can actually fly into your own brain, see brain activity in different brain regions, localized, see brain network activity with sort of Granger causal estimation. You can see your heart beating. You can see other physiological metrics through other sensors, all in a immersive avatar, simulacrum of yourself. This allows for different kinds of ways of experiencing your own state, as well as potentially ways of doing neurofeedback. But there's a potent experiential aspect of this, allowing you to appreciate the awe of and wonder of the body and the brain, and perhaps tap into more mindful states. So there's a number of other applications also, but those are some of the key ones. I've listed here 5 opportunities for future consumer neurotech. If you want to learn more about these and other interesting opportunities, there's a series of papers that now are a little bit dated, in that they were written in 2012 for the IEEE Centennial special issue of the Proceedings of the IEEE, but they do cover a good overview of this landscape. So you might want to read those. Those are cited at the bottom. The first opportunity is the development of unobtrusive multimodal sensors and systems for pervasive measurement of brain and body activity in natural, real-world environments. This is essential for consumer neurotech, that we're able to measure brain and body states in the real world in ecologically valid scenarios. Key challenges and opportunities there include developing plug-and-play systems for plug-and-play use and interoperability with these sensors, improved sensor ergonomics and aesthetics, standardized data acquisition, storage, and metadata that allows you to do analytics on that. The second major opportunity is improved multimodal signal processing and machine learning that can deal with artifacts and noise, acquired in real-world environments, extract informative features, perform behavioral and contextual modeling, and then ultimately neurocognitive state identification, again, in complex, real-world, noisy environments. And by noisy, it doesn't just mean artifacts. It means that you have poorly labeled data. It means that you have many confounds. So this is a real important machine learning challenge. Some of the key drivers here will be increased focus on multimodal data fusion, as well as so combining data from multiple sources, not just brain, eyes, heart, behavior, as well as being able to infer neurocognitive state from behavior. So that entails modeling generative relationships between neurophysiological measures and multimodal or behavioral measurements. So ultimately, once that mapping is established, you can potentially use multimodal behavioral measures to infer brain states at some level of accuracy, so you don't have to necessarily wear the sensor tech all the time. You can use behavioral measures to make at least coarse inferences. The third major opportunity is large-scale population inference from heterogeneous data. This basically means acquiring data from lots and lots of different individuals in lots and lots of different contexts, and being able to do mega analysis on this to be able to identify the needle in the haystack that transfers across different individuals that may indicate a particular neural or cognitive state that is either devoid of that doesn't depend on the specific context, or that is very precise in a specific context. Some of the drivers here include neuroinformatics technologies, tagging of data, containerization, as well as the development of machine learning techniques for universal classification and transfer learning. The fourth major area is using these population level insights to then better develop individualized and contextually dependent models. By contextually dependent, we mean building a model that essentially can utilize all of the historical information and context from an individual, location, activity, things like this, to potentially improve that neural state decoding. And then fifth, but incidentally, perhaps the most important thing we need to think about right now are standards, ethical frameworks, and then ultimately technology platforms that can allow consumer and health applications to rapidly build on emerging novel research and methods in a principled manner, scientifically validated manner, with rigorous ethical frameworks at the foundation of these technologies. So this includes things like privacy, transparency, equitability, user autonomy and cognitive liberty, and other key ethical considerations that must be thought of in advance of the new wave of consumer neurotech, not as an afterthought. It should be built into the fabric of the technology. So I'm just going to give you a quick review of just some of the key moments in BCI history so we can see the context in which consumer neurotech has emerged. As we all know, the origins of BCIs date back, roughly to 1924. If we think about Hans Berger's invention of EEG as that moment, then about 50 years later, Jacques Vidal would define brain-computer interfaces working on ARPA-funded project. This was intended as a computer-mediated system to augment or supplant neural input and output, thereby enabling man-machine communication. At that time, we saw the early use of BCIs in the arts, and actually happened before the definition of brain-computer interfaces. So there was this experiential aspect to it that was really coupled to this idea of the cybernetic self, the idea that humans could improve that human potential could be expanded through cybernetics or through computer assisted and neural interface technology. This idea was already present well before or around when the first classical definitions of BCI emerged in the academic sphere. Then we saw about 10 years later, interestingly, the first kind of attempts at consumer neurotech. This was the Atari MindLink EMG controller, a headband that recorded your muscle activity in your forehead. It was a categorical failure. It was never released, probably one of the 10 worst game controllers ever. But what was interesting is that it demonstrated a clear attempt to take this early technology and start to think about its use in a consumer context. Some years later, we saw the first human with a brain implant for prosthetic control. And then about 10 years later, we saw the first successes of the BrainGate program for artificial limb control. And then the advent of other really impressive breakthrough technologies like optogenetics. And it was right around this time in the mid to late 2000s that we saw the first consumer BCIs and wearable EEG systems also emerging in a really competitive context. And then 5 years later, we saw the emergence of breakthrough implants like neural dust and stent trodes, and then Silicon Valley's major thrust into BCIs with $100 million plays into the space, ultimately creating a large amount of interest in the potential of neurotechnology in the industry spaces and extending into the consumer spaces. One thing that's important to note is a sort of accelerating geometric progression of certain key advancements in the field. There is a overall power law that governs a lot of these kinds of technologies. I think with neurotech, we're more in the early phases of that, whereas in computing, we're already well into the exponential swing. But there is that acceleration, and we can expect that to progress in the coming decades. Mark Weiser, who is the CTO at Xerox PARC in the 90s, he had this famous statement where he said the most profound technologies are those that disappear. They weave themselves into the fabric of everyday life until they are indistinguishable from it. And he also said that the more you can do by intuition, the smarter you are. The computer should extend the unconscious. Technology should create calm. And these are two phrases that I think are very important when we reflect on what the ultimate intent of neurotechnology should and will be, inevitably. You know, one, to disappear completely, and two, to ultimately act to extend the unconscious and create calm. When we look at the progression of neurotechnology, say from 1973 to the present, we can see that the earliest systems occupied an entire room. This was Jacques Vidal's BCI lab at UCLA around 50 years ago. As we progressed from over the last few decades, we've seen miniaturization of that technology, making that technology smaller, more invisible, using embedded processing and cloud computing to offload the computation or to make the computation something that can be carried out in a small chip. And ultimately, the technology can be fit in one's hand, it can be worn on the body. So the technology is disappearing and becoming more ubiquitous. The same capabilities that would have taken a whole room now can fit in your hand, can be worn in your ear. This is an example of some of these new kinds of possibilities for interfacing with the brain, connecting your brain to the Internet of devices. I'll just play this.
Alexa, ask Neuroscale for my average relaxation level over the last 5 minutes.
Let's hold it up so she can respond.
Your average relaxation level over the last 5 minutes was 36%. Not bad, but maybe you want to try taking a little break?
So what she did there is she asked Alexa what her relaxation level is. And Alexa, through the Neuroscale platform, which is Intheon's technology platform, was able to acquire that state, which is being acquired from data from a wearable sensor in her ear that is tracking her brain, her heart movement, infer a cognitive state from that and provide that to Alexa within a second or so. And so this enables new ways of interacting with the world around us. As we look towards 2035, what we're going to see is a progression from wearable to implanted BCIs, at which point they'll disappear altogether as they become sort of woven seamlessly into our bodies. Importantly, that will take time. So we will not see consumer implantable BCIs for at least 15 years. This is a categorization of some of the current and emerging neural interface hardware for reading and writing to the brain. We have near infrared and EEG type systems on the scalp, but as you penetrate into the body, you get increased precision as you're able to listen more closely to neural activity. Also, you get increased risk, you get increased invasivity. So there's an increased barrier for consumer adoption as you move deeper into the brain and penetrate through the skull and into the brain. I'm not going to go into all the detail in each of these technologies, but suffice it to say, some of these are really impressive breakthrough technologies that have the ability to perhaps allow for precise measurements in a way that is less invasive, less risky than other invasive technologies, but do allow for high fidelity neural signal recording. And that may include potentially things like intracalvarial, intravascular type interfaces, and potentially even very, very small other injectables and implantables that might be coming in the next 15 years. This slide is a representation of a subset of different neurotech players in the space, color-coded by regions. I just want to point out that medical BCIs are generally more prevalent in Europe, but that's changing now, but consumer BCIs are more evenly distributed across Europe and the US. This is reproduced from Pooja Rao's lovely analysis in her article. While consumer BCI companies are more, one thing to note about this, aside from the fact that while consumer BCIs are more kind of evenly distributed and there is this then balance for medical companies that shifts more to Europe, that much of the medical device company traction has taken quite a number of years to be achieved. So you can see the green bubbles here are companies that have received FDA approval for their implantable devices, the least of which has taken in 10 years, or at least is 10 years old as a company. It takes, generally 5 to 7 years for a company to achieve FDA approval for a medical implant. And that is a litmus test for emerging invasive neurotech companies to transition into the consumer space. So that's an important consideration here. They'll need to cross through that clinical barrier first and prove the capability and safety in the clinical market before they can transition effectively into broad consumer use. This is a breakout of categorizations of current and emerging consumer neural interface hardware. This is consumer again. So the interface modalities here are dry and wet surface EEG, optically pumped MEG, near-infrared spectroscopy, and then other types of biosensors like EXG type systems, ECG, EMG, GSR, peripheral nervous system measurements. There's also a number of different inputs that can be realized, including transcranial current or magnetic stimulation, focused ultrasound, photobiomodulation uses light to stimulate the brain, peripheral nerve stimulation, sensory neuromodulation using haptic, photic, or oral modalities to essentially stimulate or change brain function just using the senses themselves. And then there's a range of emerging form factors from head wearables, classic, helmet type systems or headbands, to eyewear or head-mounted displays, VR, AR integrations, hearables, we mentioned that earlier, clothing wearables. And then in the future, we're going to see more and more of these other capabilities like subcutaneous motes, maybe IOTA Biosciences might be the breakthrough for that, maybe others, epidermal tattoos that are basically flexible polymer electronics that can just be kind of tattooed onto your body and measure your body or brain activity. And then, of course, body wearables are also a major class, the sort of Fitbit-like devices, but can be worn anywhere on your body, measuring neural function and possibly also brain function. These are some of the representative non-invasive EEG hardwares that are currently used in BCI. The important thing to note here is that as you move towards consumer devices, you get lower channel density and therefore lower fidelity. Just an important consideration because a key milestone for consumer BCIs is to develop wearable lightweight systems that have a lot of electrodes, thereby allowing them to extract more information from the brain with higher fidelity, remove artifacts and such. This is an example of pervasive neurophysiological state assessment, again, using a hearable, similar to the Alexa example. This is actually me walking around, and it's just measuring my brain and body activity, processing that in the cloud, and able to see that on my phone. So we're able to get to that level of reasonable measurement. Again, this is one channel in your ear, so it's definitely not like localizing brain function. It is coarse, to put it mildly, compared to a, say, 16 to 64 channel EEG system. But you do have that ability emerging now, and we'll start to see that use in the consumer space. Outside of sort of devices and wearables, we can think of platforms that enable consumer neurotechnology. One example of that is technology that Intheon's developed called the Neuroscale platform that basically just allows you to ingest lots of different types of data from sensors, process that, and then build applications on that through a simple web API. And what this enables you ultimately to do is to be able to quickly spin up a sort of anytime, anywhere brain state decoding application by just streaming data to the cloud, deploying a pipeline, and getting that result back without really needing to know anything about how to implement the neural state decoding. So that's key for consumer applications, that ease of access, ease of use. We can also see in this examples, one of which I'll show here. This is an example game that was built on the Neuroscale platform. I showed you this earlier. This is that neurofeedback game. But basically, this application is pulling brain data from, oops, sorry, that's something's lagging on here, but it's pulling brain data from the EEG device, sending that up to the cloud alongside other physiological measurements, decoding it, and then the game just subscribes to the neural state. So the app developer actually was able to build this in about a weekend or to a week without needing to know anything about BCIs, just utilizing the neural state decoding pipeline that was already available to him. We can also look at the broader BCI landscape. This is just a number of the representative companies in that space. And in that, we can see how funding generally is being allocated. These are not all consumer neurotech companies. I'll just show them the next slide. But these are a lot of the different companies in the space. And the important thing to note here is that there's been a small number of companies that have received substantial funding exceeding 100 million. Most of these are invasive, but not all, like MindMaze is not and has a consumer play. Kernel has a potential consumer play. Facebook has made big investments into this space. What the outcome will be, it remains to be seen. But a third of the companies have funding in the $10 to $80 million range, some of which are consumer neurotech companies. And then about half the companies are 1 to 10 million, which is pretty typical. A lot of companies receive money still from grants and non-dilutive funding, such as the ones on the right. These are some of the representative consumer neurotech companies categorized around enabling hardware platforms, assistive and communication technology, quantified self-wellness tech, sleep tech, human performance neurofeedback, neuromod, some enabling software platforms, and then human-machine interaction systems. This is not exhaustive. There are other companies in addition to these, but these are some of the ones that are out there, specifically in the consumer space. When we look into the future, this slide's actually taken from an older report from the FBNCI Horizon 2020 project, but we can look at some of the key sectors that are expected to grow, and this still holds relatively true today. Health and neurofeedback are fast-growing sectors with relatively high market value. Neuromodulation has emerged as one of the most promising areas for near-term growth. Entertainment and gaming are still relatively substantial, large user adoption there. And then assistive technology and smart home control is now growing, in part due to an aging population in the EU, US, Japan, and elsewhere. With this slide, I just wanted to point out that about 60% of all neural interface ventures derive their tech from public institutions currently, like universities, government agencies. The remainder are entirely privately funded. And the percentage that are privately funded is steadily increasing. And an interesting index of when BCIs are about to cross over into sort of massive mainstream growth is basically when private funding substantially exceeds public and government funding. And important thing to note is that for consumer devices, that's already crossed over. So that indicates that this market is ready to expand rapidly, which is what we're starting to see with BCI wearables entering the mainstream market. So in the next 5 years, I think we'll see a lot more consumer players in this space. And again, this is neurotech broadly defined. We don't just mean EEG. We mean generally the ability to interface with the nervous system through multiple modalities. This slide is just to point out, this is from the SVB Trends in Neurodevice Investing report, but basically this is just to point out that there's massive interest in neuromodulation as a therapeutic. This represents over 70% of financing in the of neurotherapeutic devices in general, nearly 90% of the invested equity. What is interesting about this is that there will be a crossover from the neuromodulation clinical space to the consumer space. And that will be achieved primarily through increased scientific validation, safety, unobtrusive form factors, and cost reduction. So, but we can see an inheritance ultimately over the coming years of the growth of interest and investment in the clinical space, catalyzing consumer growth. And that will feed back into the clinical space as there's more adoption, more awareness of the potential of neuromodulation as a breakthrough technology. I will skip to just this slide, which is just to point out that hearables are a really promising form factor for consumer neurotech. This is just showing kind of the growth in millions of devices adopted of earbuds over a number of years, and then the projected growth into 2025. This is from Frank Fitzpatrick's amazing article, or I think really great article, 5 Key Hearable Trends for 2021 that just came out. There are some key drivers for this, for the use of hearables, including integrating sensor tech. That includes sleep and anxiety management, biometric validation of audio-based wellness solutions, improved audio experiences, and then ultimately intelligent personal assistants. And the key challenges are obviously like signal to noise is not that great. There's limited spatial coverage for measuring, say, brain activity. And those things need to be improved, but there is a real potential for hearables in the coming years if you can find the right balance of signal and noise, biomarkers that you can identify inside the ear, and then of course a key application, which will primarily, I think, be in sleep, anxiety, and wellness as its breakout space. So as I'm just wrapping up, and I'm a couple minutes over here, so I just want to give you some expectations from 2020 to 2025, what we'll expect to see, particularly as it pertains to consumer neurotech. One is a shift from research and development applications to more specific end user products that are driven by larger market demand. Second, we're going to see as I said earlier, a lot of health-oriented BCI applications, particularly in wellness and sleep tech. Sleep tech is a massively growing market, is a huge need, huge benefit to humanity. You know, sleep is the flywheel on which many different things from immune function to well-being are anchored and rest. So improving that would really help humanity. The entertainment and gaming sectors still have significant potential, and that's primarily due to early adoption and other factors, lots and lots of potential customers there. And the ease of integration of BCI tech with evolving human input devices like AR, VR. Interestingly about this, as that expands out, that will lead to significant investment in further low-cost tech and fab of devices that's going to have a stimulating influence on the health-related markets. Personal neuromodulation, I think, is the most promising sector in the near term with big growth potential. And this also, as I said, is catalyzed partly by the clinical growth, which big pharma companies now are starting to make big plays in. Just to reemphasize, practical consumer intracranial implants are at least 15 years away, I think. So we're not going to see in 5 years consumer implants. That's not going to happen. In brief, there's other areas and sectors that are really important to think about, like standards. I mentioned that earlier. There have been some attempts at this. There are a growing number of attempts in the consumer neurotechnology space to create brain-computer interface standards and neurotech standards. One of these standards is a consumer file format called the Attune Container Format that was produced in combination with the Consumer Technology Association. There was also 4 other proposed standards that are still in their infancy. The IEEE has been making extensive inroads into standardization, and I already mentioned the EU Horizon 2020 roadmap, which covers in quite some breadth some of the standards goals. I recommend that you read that. But standards is a really key component of the crossover from research and medical. Actually, it's part of the medical, but the crossover from research into consumer and medical applications. And then I would be remiss if I didn't just mention that it's really key that we focus on ethics. Stewardship, sovereignty are things that need to be thought about at the inception of the development of these technologies, not as an afterthought. You know, we're not owners of tech. We are stewards of it for future generations. We need to think about the impact of the technology we're building for our children and their children. And sovereignty is a key thing to think about. Human agency, autonomy are inviolable rights. Cognitive liberty is an inviolable right. So we need to use neurotech to preserve and enhance rather than undermine those rights. And the one thing I want to point out is that ethical considerations for consumer tech may differ from their clinical counterparts. So it's not necessarily the same thing. There's additional considerations, you know, separate from, say, just safety and effectiveness that really need to be considered in the consumer space. They may apply to the clinical space too, but that includes things like fair access to tech, privacy of brain data, you know, the right to object to automated processing, ethical boundaries of cognitive enhancement. All these need to be understood better as and then built into the fabric of the emerging technologies in the consumer space. So in closing, I'm just going to say that there is a special issue in Frontiers in Neuroergonomics that will be coming out. It's just being announced now, just starting on advances in consumer neurotechnology. This is part of the working group that Marie and others on this call are a part of. The goal here is really to bring together academics and companies and industry thought leaders to publish peer-reviewed papers that focus on several different aspects of the consumer neurotech space, from enabling technologies like emerging hardware platforms and software platforms, through what are the consumer form factors that are likely to actually work in the consumer space, wearables, epidermics, VR, AR, non-contact, et cetera. And then key things like, you know, allowing companies to publish their scientific validations of their product efficacy. You know, it's really key that products are scientifically validated. So there's a forum for that here. Design and user experience considerations, ethical frameworks, and consumer neurotech standards can all be considered within this special issue. So just inviting anybody who's interested in submitting to that to consider that as the call goes out for that special issue. We'll look forward to those submissions. So for any additional learning resources, please reach out to me Wow, I went a bit over, so I'm certainly into my questions, but I hope that gave you a good overview of where the landscape is and what the opportunities are for that space in the coming years across academia and industry. Thank you.